Okay, now next is 6.3, that is format string. We are at 6.3 in this chapter.
The other vulnerability is format string. So basically, a format string is an ASCII string that contains text and format parameters. So that contains, so this is the format parameter and the text. So everyone might be aware of the C language, and this is the basic statement to print out any data in the C language. So suppose you want to print the name on the console. So you have written this statement printf, which is a library function in C. My aim is percentage %s. So percentage %s stands for this string and ABC. So it will give you an output ABC on the console. So basically, what are these format string vulnerabilities? So format string vulnerabilities are a class of bug that take advantage of an easily avoidable programmer error. So if the programmer passes an attacker controlled buffer as an argument to a printf or any related function. So there are different functions which can print the strings on console or which are used by the language to give you some formatted outputs, to print the string in different formats. So suppose fprintf, sprintf. So these are the different functions to print a string. So the attacker can perform writes to arbitrary memory addresses. To give you an example of this format string vulnerability, you can refer this a simple C program with format string vulnerability, wherein we have declared a buffer with 100 characters. So it's a buffer array, and we are using string copy function of the C language, wherein we will print the buffer which has been input by the user. So since printf has a variable number of arguments, so printf is a library function of C and it can have a variable number of arguments. It must use the format string to determine the number of arguments. So basically, if you see the earlier printf statement wherein we have declared this percentage %s, and in this function we haven't used this percentages or any percentage signs or the variables which the C language supports. So this to determine the so basically that percentage %s is used to determine the number of arguments that are being passed to the statement. So if there is no argument with being passed to this printf function, so it can accept n number of arguments. And in this case, so what user can do is user can, or the attacker can send you this number of strings more than the accepted one. So let's suppose we only wanted to, so the developer has only developed this application to show single value, but if an attacker uses this percentage p, so n number of arguments, then there is bug in this program. So you can try this on your machine as well. So if you enter this percentage p, so n number of percentage p, it will print the next n number of memory addresses, and what memory contains the data. So if your data is sensitive, all your data is exposed by this function. So in order to avoid this to happen in your program, or an attacker attacker to misuse this program, what you can do is you can just use proper number of arguments inside the printf function that will minimize your vulnerability of this code. Now, so basically preventing format string vulnerability is not that difficult. So to solve this issue, what you can do is specify a format string as a part of program, not as an input. Most format string vulnerabilities are solved by specifying percentage %s as format string and not using the data string as format string. So this printf buffer is an example of directly using the data instead of format string. And this printf statement, we are using format string and then we are using data. So this will minimize the format string vulnerability. The other thing you can do to prevent format string vulnerability is, like, if possible, make the format string a constant. Extract all the variable parts as other arguments to the call. So it's difficult to do with some internalization libraries, like libraries don't allow you to format these things, but wherever possible, you can use this second approach as well.